Hello everyone and welcome to On the Spot STEM. Today we will be tackling the AMC 10B number 20, which is the same thing as the AMC 12B number 15 from the 2019 AMC contest. Now this problem gives us a circle of radius 2, which is being intersected by this semicircles of radius 1, where we want to find the area of this shaded region in terms of this weird expression. Now, this problem may look complex at first because we don't know how to find this shaded region, but usually in situations like this, it helps to break up this large geometric shape into things that we know how to solve for. So I took the liberty of expanding this diagram below. So let's look at how we might be able to split this up. So as you can see, we can easily calculate the area of a semicircle here. So let's label this as A. Remember, we want to break this up into things that we know how to solve, and I think we know how to solve A because it's just a semicircle. Let's also split this weird region into B, because that looks like another figure we might be able to break away from the others. And then finally, these weird little triangle things we can label as C. Now we want to evaluate expressions for A, B, and C. So let's start off with A. Well, A is going to be a semicircle of radius 2. So it's going to be equal to 4 pi divided by 2, which is 2 pi. Next, we look at B. Now, we first want to figure out what kind of arc B is. So let's draw this, because usually when we want to find the area of a sector, we draw out where it intersects these lines, and then figure out the area from there. So we know that the radius of this triangle, of this circle, is 2, so that's going to be this guy. We also know that if we draw this, the radius of this circle is 1. So we see a right triangle with a leg of 1 and a hypotenuse of 2. That automatically makes me think of a 30, 60, 90 triangle. So we get that this must be 60 degrees, so this is actually a 120 degree arc, which means now we know how to solve for B. B is going to equal 1/3 of the circle, which is 4/3 pi, which is the area of that sector, minus the area of this triangle in the middle. And we know that this triangle is two 30, 60, 90 triangles with a base of 2 root 3 and a height of 1. So its area is just going to be root 3. So now we have the area of sector B. So let's erase these marks that we made. So for C, the first thing I see is a lot of nice little points that they've given us, E, B, F, C, G. Maybe I can make use of them a little. So let's draw this out. And I'm actually seeing something pretty nice, which is that I get isosceles triangles, and I know how to find the area of these isosceles triangles because they have a base of 2 and a height of 1, because that's just the radius of the semicircle. So the area of these isosceles triangles is going to be area of EBF, which is just 2 times 1 over 2, which is 1. But now we need to subtract out these weird guys. So let's see if we can evaluate an expression for solving for these weird guys. Well, let's draw E down to here. And as you notice, this weird guy that we got over here turns out to not be such a weird guy because it's just a 90-degree sector of this semicircle. So we notice that this semicircle has radius of 1. So we want to find what 1/4 of the area of the semicircle is and subtract out this right isosceles triangle. So we want to subtract out whatever 1/4 of the area is, which is pi over 4, and then pi over 4 minus whatever the area of this right triangle is, which is 1 times 1 over 2, which is half. However, there are also 2 of these. There's one over here, but there's also 1 over here. So we need to subtract 2 of these. So we multiply whatever we subtracted by 2. So now that we've evaluated expressions for a, b, and c, our answer is actually pretty simple from here. We want to find the value of a plus 2 plus b plus 2c. So let's evaluate this expression below. We have a equals 2 pi plus 4/3 pi, and then we add 2c, which is, combining like terms together, we get. Now looking at the answer that we had to give above, we had to give a over b times pi, which in this case is 7/3, minus the square root of c, which is 3, plus d, which is 4. And we want to find a plus b plus c plus d. Well, that's 4 plus 7 plus 3 plus 3, which ends up being 17. And as we see in the problem, 17 is a valid choice, giving us an answer of D.